Hi and welcome to a new section. In this section, I'm going to explain how to use the GPIOs, which are the input-output pins on your Raspberry Pi, using Python so that you can manipulate and control and work with external devices. So for example, in this case, I've got a little circuit that we're going to put together further down in this section that includes an LED, a DHT22 sensor, and a push button, and all of those things need to be connected to GPIOs appropriately, and then using simple Python commands to be able to read the state of a button, for example, or control the state of an LED and take readings from the DHT sensor. But before that, there's a few things that I'd like to explain in relation to GPIOs to get you ready to use them later. So what you're looking at here is a Raspberry Pi B, which has the 2 rows of pins, 40 pins in total, where the GPIO header is. And this diagram shows you the various roles that each one of those pins can take and the numbers for those pins. So the first thing to remember is that most of the pins on the Raspberry Pi GPIOs are multi-purpose. It means they can do more than one things. And even this diagram only shows some of those capabilities for most of those pins. So for example, pin 19, this one here, shows us on the diagram that it can play 2 roles. Like the first one is a general purpose input and output. So we can use this pin to control an LED, for example, or to read the state of a button if we configure it as an input. But it can also be used as a MOSI for SPI communications. On the other hand, you'll see pin number 25, which only has a single purpose. It's to be a ground signal, and so on. A lot of pins actually have 4, 5, maybe 6 different purposes that you can enable or disable programmatically as well. In this course, we'll be using some of those pins as either digital inputs or digital outputs, and we're not going to look at any of the additional capabilities that they have. Another thing that confuses people quite a lot, especially when they are coming from the Arduino, is the numbering system. On the Arduino, we've got a very simple numbering system. So we'll look at the pin, and right next to it there's a number, and we know that the number for this pin, in this case, is 7. So we'll just type 7 in our program. Down here we've got the analog pins. You can see they've got their own designations. So there's A0, A1, A2, and so on. And when we go to our sketch to write a little Arduino program, we'll just use the same notation. We'll say analog read A0, for example, and we get a number back. But the same does not apply on the Raspberry Pi. On the Raspberry Pi, we have 2 different numbering systems. The first numbering system is called either physical or board numbering system, and we've got the numbers that correspond to each of the pins directly. And you can see that from 1 we cross over to the other side, it's 2, come back to the left row of pins, it's 3, and then 4. It's very regular, as you can see. So if somebody says, I'd like to connect a jumper wire to pin 40, then without even looking at this diagram, you know that pin number 40 is the last one on the outside of the board towards the side of the board with the USB ports. If you look closely on the board, you'll notice that the silk screen, so that's the white line that goes around this header, at this point right here, right where pin number 1 is, you'll see that it's a little bit cut. It's not an angled corner like the one that you see on the other side here, right next to pin number 2. So in pin number 1, you'll see that the corner is kind of cut. So that's how you know, just by looking at it, that this pin here that I'm pointing to is pin number 1. So if another example, if somebody says that I'd like to connect something to pin number 20, which is the ground pin here, then you know that that pin is around half of the way through the header. You will have to count up to 10, starting from the outmost row of pins, because 20 is an even number. So all the even pins are on the outside of the board, so on that side, on the right side of the board. So 20 divided by 2 gives us 10, so we just count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this pin right here is the ground pin, pin number 20. We can do the same thing on the other side. So if somebody says that I'd like you to connect a jumper wire to pin number 19, 19 is an odd number, so we know it's on the left side. So what we do is we say 19 plus 1, make it a 20, divide by 2, gives us a 10, and we know that we need to count 10 down the left side of the header. So that's the first way of numbering our pins. Again, this is called the physical or board numbering system. The second system is called Broadcom or BCM, because Broadcom is the company that makes the processor that powers the Raspberry Pi. And that is how we number the GPIOs. And GPIO numbering or Broadcom numbering seem totally crazy when you compare it to the board numbering. So you can see, for example, here's a GPIO number 17. According to the Broadcom system, that corresponds to pin 11 using board system. So pin 17, pin 11, there's no really a connection between them. You will have to look it up on the schematic. Same thing goes with pin 15. Pin 15 is the same as GPIO 22, because 22 is the number of this pin according to the BCM numbering system. So 22, 15. Then you go to from pin 18 in the board numbering system to 24 in the BCM system. So there's total disconnect between these, and that's quite confusing when you get started with. In this course, we'll be using mostly, except for a few examples, we'll be using the BCM numbering system. So it's a good idea to have a chart like this or schematic like this with you so that you can switch from the GPIO system to the board system easily, and so that you can connect the jumper wires to the right location. So again, GPIOs, you can see them on this map. That's the number that you're looking for. So if somebody says that I'd like to connect a jumper wire to GPIO pin 6, if they say GPIO pin 6, if they include the words GPIO or the letters GPIO in the reference that they give you, then be sure not to connect something to ground, not to connect the jumper wire to ground, which is board pin number 6, but connect it to GPIO number 6, which is equivalent to board pin number 31. That is great. So I hope that made sense. And having said all that, what we'll do next is we are going to move on to having a look at how to use Python to manipulate the GPIO pins. And to do that, I'll be using my Raspberry Pi 3. Now, another interesting tip that I should mention here is that in the previous section, as I showed you how to install Raspbian on your Raspberry Pi into some simple configuration, I did all that on this Raspberry Pi, an early generation Raspberry Pi Model B. And what I did once I finished setting up this Raspberry Pi was to simply remove or switch it off, then remove the SD card, plug the SD card onto my Raspberry Pi 3 and boot it up. And without any other modifications, the Raspberry Pi 3 just booted properly. The operating system that I configured on my original Raspberry Pi just worked very happily on the Raspberry Pi 3, which is also a very interesting thing to keep in mind for future reference. A great advantage of Raspberry Pis across the line from earlier models to later models is that they are very much compatible, especially as you're going forwards. So it's possible to get an operating system that you set up on a Raspberry Pi 1 or 2 and use it with your Raspberry Pi 3, and it will just work because the Raspberry Pi 3 has got compatible hardware with earlier generations. You're not going to be able to go backwards, of course, because Raspberry Pi 3 has hardware that the Raspberry Pi 2 or 1 don't have, in particular the wireless networking and Bluetooth. So going backwards will be a problem, but going forwards seems to be working just fine. So let's move on to the next lecture now, where we get started with Python. A lot of pre-written software that we can use in our Python programs, and there's a lot of really good documentation. And Python as a language is one of the best languages out there, especially for people that are starting with programming right now. Our application, as we'll be developing it throughout this course, is also based on Python. It is a Python application. So I'd like to introduce you in case you've never worked with Python in the past. Now remember, of course, that Python is a very big topic, and there are other courses and a lot of books and, of course, resources online that you can take in order to become a lot more familiar and a lot more skillful in Python. In this first lecture, I just wanted to introduce you to it just in case you haven't worked with Python in the past. And I'm not going to cover everything you'll need, of course. I'll be introducing various other features and Python programming structures and other features of Python as we need them going forwards in this course. I should also mention that there are two major Python versions that are in use today, and that is Python version 2 and Python version 3. The original version of this course, Raspberry Pi Full Stack, was recorded when Python 3 had recently been introduced. So the course itself and the application was based on Python 2. This version of the course, the new version of the course that you're going through right now, will be based completely on Python 3. So all the examples that I'll be showing you here and all of the code that we'll be working with later on in this course will be based on Python 3. Great, let's begin. I'll use SSH to log on to the Raspberry Pi using the Pi user, and that is at 192.168.111.36. I've got a new IP address for my Raspberry Pi because since I recorded the last set of videos in the previous section, I switched my Raspberry Pis. I went from the Raspberry Pi 1 Model B to a Raspberry Pi 3B just to take advantage of the Raspberry Pi's 3 faster speed. And all I had to do to make that possible was to just take the SD card out of my old Raspberry Pi 1 and plug it into the Raspberry Pi 3 and power it up, and it just worked. So here we go. And the password. Great. So here we are logged on to my Raspberry Pi Full Stack version 2. That's a host name that I've given to my Raspberry Pi, and I showed you earlier how to do this. Raspbian Stretch Lite comes with two versions of Python. So the first one, you can reach it just by typing Python. So if I do Python and then use the version switch or parameter, hit enter, and that tells you which Python version 2 shipped with Raspbian. It's 2.7.13. But if I want to use Python 3, I need to explicitly call the Python 3 interpreter. If I pass the version parameter, I can see the version number being 3.5.3. Now to use Python, you have two options. The first one is to write your program in a text file and save it on the file system and then execute it. And I'm going to show you how to do that later. But the easiest way that doesn't involve creating any files and using text editors is to use the Python command line interpreter. The command line interpreter allows you to simply type in Python commands on the command line and they are executed immediately. So to start the Python 3 command line interpreter, just type Python 3. There you go, and we've got the 3 arrows, which means we can now start typing commands. How about we use Python as a calculator? So 1 + 1, 2. Not very hard at all. We can do all sorts of arithmetic calculations. Let's say we want to raise 2 in the power of 3, so that's 8. When you want to write an instruction and also provide a comment for the human user, you can do it using the sharp symbol. So for example, if you want to make a division and provide a comment, let's say this is a division, you can do it like that by using the sharp symbol after the instruction that you want to execute. We can use variables to store results of our calculations. So for example, we can use, say, D, or it could be like a division result variable name. You can come up with any variable name as long as it's valid, and that means use, say, alphanumerical characters with no gaps, and underscores or minus signs are also valid characters. And then we can do the calculation in here. And now you can see that there is no result coming back. That's because the result of this calculation was stored inside the division result variable. And if we want to see what's inside this variable, we can just copy it and paste it, and it will give us the variable back. Or if we want to be more explicit, we can say print and the name of the variable, and it will give us the variable back. This is the use of parentheses with print is one of the big differences between Python 2 and Python 3, where in Python 2 you were able to do something like this. And of course, in Python 3, this gives back an error result, but you can understand how the missing parentheses could cause people to get confused. And one of the improvements that they made in Python 3 was to include the parentheses just to make it a little bit easier to dissect what is it that we are printing. I'll give you another example. We can see that the result of this calculation is a number with a lot of decimals. So let's say that we'd like to round that number up to the last to 2 decimals. So we can use the round command, and we could say that I'd like to round. I copied the wrong thing. Let's say that we'd like to round the contents of division result to 2 decimal places. And that will give us 5.67. A lot of the work that we'll be doing in this course will be dealing with strings. So strings are a series of characters, one right next to the other, and that's how we make words. We put characters together. So we can use the quotes, single quotes, to create strings like that. So there is a string, and of course we can store that string, let's call it str, in a variable. So like this. And now the contents of str is tech explorations, or we can also print it like we did earlier, like that. But just like we can do calculations between numbers, we can also do sort of, not exact calculations, but we can do functions between strings. So let's say that we have the string. So let's say that we'd like to stick 2 strings together. I can take the string that we stored in variable str and add another string. In this case, it happens to be an empty character, and we can put then another string there, such as RPI full stack. And what we'll get is the concatenated string of whatever we had in the variable, plus, this is the concatenation symbol, some empty space in between the single quotes, plus the string that we have in between the single quotes. Another interesting thing that you can do with strings and numbers is to use a star operator. So for example, let's say that we'd like to repeat take expressions a bunch of times, like 3 times. What you can do is you can say that I want to repeat 3 times using the star operator the contents of the variable str. That will give us take expressions 3 times. Of course, a string can be seen as an array of characters. So an array of characters then means that we can individually work with each one of the characters in this array. So if we'd like to know what is the letter at position 5 in this string, we can just request for it like that. And that letter is E. We can also define a function, and then we need to provide a name for our function. Let's call it str operation. And we can pass parameters, like in this case, I'd like to pass the parameter str. Actually, I'll call it, just to differentiate between the variable that we've already created earlier and the parameter that we pass to this function, let's call it strn for string. And then we've got the 2 dots, the hyphen. Press spacebar and you can see that the command line interpreter, instead of producing the prompt with the 3 arrows pointing to the right, it's got 3 dots, which means that it hasn't executed anything because it's waiting for us to complete typing in the expression. When we create a function in Python, it's very important to be aware of indentation rules. In Python, we can indicate to the language that some code is nested or belongs within a certain block of code by using indentation, either created as spaces or tabs. In this case here, I'm just going to type in 3 spaces, 1, 2, 3. So I've created the indentation, and at this point now I can write the expression that I want. So let's say 3 times strn, which is the variable that I'll be passing on to the name, onto the function itself. Then I'm going to hit enter. Notice that the command line interpreter still gives me the 3 dots, which means that it still expects me to continue adding more content to this function. But at this point, actually, I want to finish. So in order to tell Python that I'm done defining this function, I'm going to hit enter one more time, and I'm going to get the prompt back. So let's use this function now. Remember that the name is this, so I'm going to copy it and paste it here. And I want to pass a little string. Let's keep it simple and say hello. And I'll put a space at the end as well in order to not have the result of 3 hellos being stuck together. So I hit enter and nothing happens. Take a few seconds to think about why nothing has happened. Now the reason that nothing happened here is that because when I defined this function, I didn't actually tell Python to print it. So I didn't use the print keyword here so that the result of this concatenation is actually printed. So that's a little bug. In order to fix it, I need to go back and redefine this function. So again, use the def keyword, pass the name and the parameter that I want for the construction of this function, hit enter. Now 1, 2, 3 spaces. I'm going to say print, open the parentheses, and just copy the expression that I want evaluated, and then close the parentheses. First return and then the second return to get out of the function, and I'm simply going to call the previous invocation of this function with the hello plus a space as a parameter. And now I've got the 3 hellos. Well, yet another way that you can go about this is to redefine this function, and then instead of doing the printing and the evaluation in a single line, you can now opt to have an internal variable. Let's do that now. So I'm just going to call this variable a due to lack of imagination, and I'm going to copy the expression, put it in here. Then in the next line, I'm going to say print a with a parenthesis like that. So we do the evaluation in the first line, and then the assignment of the result of this evaluation to a new variable. And then in the second line, we'll print out the contents of variable a. So enter and enter again to get out of the function definition. And let's call the same function again. Great. So you can see exactly the same outcome as up here. Of course, things can get a bit more complicated. So from here, for example, let's say that I want to make my function a little bit more elaborate, and instead of having a fixed number of repetitions for the string, let's say I'd like to make it a bit more flexible. So I'm redefining now the string operation, and I'm allowing 2 parameters. The first one is the string, just like before. The second one is for a number that I want to pass. So I can do the same string evaluation, but now instead of 3, I can have an arbitrary number that I can change each time I'm invoking string operations. So hit enter, and then 3 spacebar hits, and let's make this a instead of 3 times strn. I'll make it num times strn. Great. The second line is the same, print a, and enter and enter. And now, instead of just sending hello, we'll send hello plus a number. We've got hello, hello, and 3, and 4, and so on. So what you just witnessed is that we can create functions that can enclose, in this case, some simple functionality, but later on we'll be creating much more complex functions, and then we can pass parameters to those functions so that we can get the function code, the block of code that is included with the function, to operate on any arbitrary set of parameters that we provide. At this point, I've only scratched the surface of what is possible with Python, and I do recommend at this point, if you're not familiar with Python, to take a little bit of time to have a look at the Python tutorial on the python.org website. It's a very good tutorial, and you don't need to read all of it, of course. Just a few introductory sections would be enough. As I'm introducing more Python features, I'll also be explaining what they are and how they work, just to make sure that everybody stays with us as we are going through the building part of the application. of the command line interpreter. With Raspbian, you get a bunch of text editors. One of them is called VI. So VI is a very, very old text editor. And Vim, V-I-M, M stands for improved, is a version that is totally open source, unlike the original VI, which was proprietary until eventually it did become open source itself. But Vim, or VIM, improved, was open source from its very beginning, and it does have a few advantages over the original VI, such as, for example, syntax highlighting and the ability to work with network protocols like SSH and HTTP. And you can actually have split screens and a lot of bells and whistles, out of which we only really need some very basic features and functions that I'll be showing you in this lecture as well. And the nice thing is that Vim also comes built in to Raspbian Stretch Lite. And the first thing that I'll do after getting into Vim is to get out of it. Now, to get out of Vim, you need to hit the escape key once in order to get into what's called a command mode in Vim. So you hit the escape key once, no matter where you are. In Vim, there are two modes. The first one is the command mode, and the other one is the editing mode. Right now we are in command mode since we just got into Vim. We haven't actually done anything. But if you are in editing mode and you need to exit Vim, you need to get first into command mode. This is going to become muscle memory very quickly, so don't worry about this if you are feeling a little bit confused right now. If you are in doubt of where you might be and you want to get into command mode, then just hit the escape key. Then use the shift key and type in the hyphen symbol, just like that. And you can see that now down the bottom line, you've got the hyphen, you've got a blinking light, and that indicates that you are in command mode. As you can see from the instructions here, to get out of Vim, just type in Q for quit and hit enter. And that's all there is to it. At this point, I'd like to use the full version of the Vim text editor. So that's Raspbian only comes with a smaller version of it. So I need to install it. And to do that, I'm going to use the apt-get tool that comes with Debian operating systems. So let's do that. I'm going to say sudo apt-get install Vim in order to install this application as super user. And say yes to download the necessary packages. Great, so now we've got Vim installed. We can try it out and you can see that Vim starts. So this is version 8.0.707. Great, let's get out with command mode and Q, and let's use Vim to create our first program. We'll call it example.py. So the py extension just tells me that this is a Python program. So inside Vim, before I can start editing, I need to hit the I key in order to get into insert mode. I hit the I key and you can see down here, the word insert appears. So now I can start typing. So let's begin typing in the program that we were working on in the previous lecture as well. So here I just want to define a function called str operation, and I want two parameters, one called strn and the other one num. Don't forget the hyphen, and you can see that Vim, being enhanced or improved, automatically intents my cursor. So because it realized that I'm creating a function in Python and that the block of code that I'm about to write belongs inside the definition of this function or inside this function. So I didn't have to press a tab key or a spacebar key to indent the line that I'm about to type in. So here I'm just going to continue with my program and say this is num times strn. Hit enter again, automatically takes me to the right indentation. So then print a. One more, enter. So at this point, I want to go back to the beginning of the line in order to indicate to Python that I'm finished creating this function. So I'm going to hit enter one more time to get separation from the previous line, and then the backspace key to get the cursor to the beginning of the line, of the next line. And just like we did in the previous lecture, I'm now going to invoke the operation function and pass in a couple of parameters. Let's make the first one hello with a spacebar, and the second one, give it a numerical 3. Great. Now at this point, I'm done typing. I'm going to hit escape once and have a look at what happens down the bottom left corner of the editor. So it disappears. So I'm not in insert mode anymore. Now I'm going to use shift and type in hyphen, and I'm now able to use the W command in order to write the buffer, the text that I've typed in into the file system, into example py. You can also, in Vim and in VI, you can combine multiple instructions together, multiple commands. So you can say, for example, I want to write and then to quit the text editor. So you do that using W and Q together. And when you do that and hit enter, you get out of Vim and back into the command line. So now we've got our little program here called example py. And let's use Python 3 and example py to execute it. And there you go. Hello, hello, hello. I'd like to make one little modification to this program. I'd like to be able to specify on the command line when I invoke the program the string that I'd like to pass, as well as the number of repetitions. Something like this. I'd like my program to work like this so that it's flexible, so that the program can be manipulated by me providing parameters on the command line instead of being fixed every time that I execute it. So what I'll do is first, because I don't want to lose my original program, is I'm going to make a copy of this original program into a new file. And to do that, I use the cp command. Cp stands for copy. And I want to copy example.py into example2.py. And I'd like to then edit the contents of this little program. So I'm going to use Vim again, and then tell it which program I'd like to open, which file, example2.py. And there we are, back to the program that we wrote a little bit earlier. For Python to be able to read parameters that I type on the command line when I invoke it, I need to invoke what's called a module. It's like the equivalent of an Arduino library, which is code that has been pre-written that completes certain functionality that is also useful for my program. And in this case, there is such a module that allows me to read into my program text that I've typed as parameters when I invoked the Python program. So that's what I'll do now. The first thing that I need to do before I actually use this imported code is to import the module. So I'm going to type I to go into insert mode. Then with my cursor blinking right under the D letter, indicating that's where the cursor is, I'm going to type in 1, 2 returns just to give me a couple of lines on top of the function definition. And then I'll say import sys. So the sys module is the system module. It contains a lot of useful functions that allow me to interact with the operating system. So sys contains a function that is very useful in my case here. So I'm going to use my mouse, and since I'm using Vim, I don't have to use the arrow keys to move around the editor. I can just point and click with my mouse, and I can even highlight like that. So I'm going to remove the fixed string hello, and instead I'm going to replace it with sys.argv1. So what this says now is I want this function, which belongs in the sys module, to look at the command line arguments and pick the first one of those command line arguments, whatever I typed there, and place it right here in this argument of the string operations invocation, the function invocation. And I'm going to do the same thing with the second parameter. I'm going to say sys.argv, but this is going to be the argument in the second position of the arguments list on the command line. So grab that and bring it here. Just one thing though, by default, everything that I type on the command line is considered to be a string. So because I actually want to get a number from the command line, what I need to do is I need to tell Python at this point that whatever this value is, I want Python to convert it into a number. So I'll go to the beginning of sys.argv and type int, and then add the missing parentheses at the end so that the parentheses are balanced. And what this has done now is that it's taken the string that sys.arg has brought into the program from the command line and converted that into an integer number. And that's all there is to it. I'm going to hit escape, then write and quit the program and go back to the command line. Now I'm going to invoke, using Python 3, I'm going to invoke example2. I'm going to pass a couple of arguments. Here's my hello. I'm just going to say world as well here. That is the first string argument. And the second one, let's make that 4 times. And there you go. There's hello world, first, second, third, and the 4th time. So with this little example, let me show you the example. I'm going to use the cat command in order to show me the contents of a text file instead of going into the Vim editor. Cat just allows you to very quickly have a look inside a text file. So this little program, we learned quite a few things. First, how we can reuse code that is available to us as modules, and Python does come with a lot of very useful modules, including sys. How, of course, we can define a function with parameters so that we can do operations on the values of those parameters, and then how to invoke the Pi switched off and disconnected from everything, I'm going to implement the circuit that I've got here on this schematic. So this circuit contains an LED, a switch, and a DHT22 sensor. And these devices are connected to the GPIOs on the Raspberry Pi. And I've also marked on my schematics the GPIO numbers as well as the board numbers. So you can see, for example, that board pin number 1 is the 3.3 volt pin, conveys 3.3 volts. pins 6, 9 and 14 convey the ground signal, and then board pin 7 is GPIO 4, which will control the LED. GPIO 17, which is board pin 11, this is the data pin for the DHT sensor. And finally, GPIO 14, which is physical board pin 8, that will read the state of the button. I'll be using a mini breadboard for this, so instead of connecting all 3 ground pins to the various devices, I'm just going to connect one of them to the negative rail, and then the rest of the devices will plug directly onto that rail for the ground signal. Great, so let's start. I'm going to start with ground and 3.3 volts. So the 3.3 volts is the first pin right there. I'll use a red pin for that. So plug that right there. And that will go to the red rail on the breadboard. And I'll use a yellow jumper wire for ground, which is the third pin right there on the bottom rail as I'm looking at the board. And that will go to the negative rail on the breadboard. I'm actually reorienting the Raspberry Pi like this so that I'm looking at it at the correct orientation as I've got on the schematic. Next, I'd like to connect the LED. So I've got the LED here, and its anode is connected to GPIO 7, which is physical pin 7. So I'll plug that in like that. And I'll use an orange wire to connect it to connect the anode to pin number 7 physical, which is 1, 2, 3, 4 pins on the inside of the header. So that's 1, 2, 3, 4. That goes right there. And that will go to the anode. And then I need the current limiting resistor. And to save on a jumper wire and keep my design a little bit cleaner, I'm just going to use the resistor to plug it between the cathode of the LED and the negative rail, like that. Next, let's move to the button. So the button, I'm going to plug it, say, around here, and I'll plan to put the DHT sensor around the middle. So what we need is one end of the button to go, one pole to go to the 3.3 volts, and the other one to go to GPIO 14. And with the pin that goes to GPIO 14, we'll use a 10 kilo ohm pull down resistor to go to ground. So let's make this side the side that goes to the 3.3 volts. So I'm going to use a green wire to connect that to the positive rail of the breadboard. Then I'm going to use an orange jumper wire to take the signal from the other side of the button. Actually, I'll plug it a bit higher to make room for the resistor, and that will go to GPIO 14, which is 1, 2, 3, 4 pins up on the right side of the header. That will go right there, right next to the ground pin, like that. And I also need the 10 kilo ohm resistor between the orange wire and ground. Okay. And the last thing I need is the DHT22 sensor. Let's plug that, say, here. And I'm going to connect the ground pin first with the black wire. So the fourth pin on the right side, so that's the first pin from this side, is ground. So that will go to the blue rail. The first pin from this side, that is the power, so 3.3 volts, since we are working with a Raspberry Pi, not with an Arduino, so that's going to go to the red rail. And then I also need this resistor here, which brings up the data pin to the 3.3 volts. So I need to join, in other words, the data pin column on the breadboard with the signal column on the breadboard, like that. Okay, and the last wire is for data, so I'll connect pin number 2 on the DHT sensor to digital pin 17 GPIO, I should say 17, which is pin 11 on the header. So that is 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, 6. All right, so let's plug that there. And the other end will go to pin 2 on the breadboard, corresponds to pin 2 on the DHT sensor. All right. Great, so that's about it with the assembly of the circuit. So let's plug Let's use Python 3 to run this example, and there's two parameters that I need to pass. First is the type of sensor that I'm using, and my DHT22 type is 2302. And the next thing that I need to do is to type in the GPIO, not the board pin number, but the GPIO to which my sensor's data pin is connected to. So looking at the schematic, we know that the data pin, which is pin number 2, is connected to GPIO 17. So I need to type in 17 here. Let's try this out. There you go, there's our reading. Temperature 22 degrees, 22.1 degrees, and humidity is 57.8. We can also have a look inside this script to understand how it works, because we'll be using this as a sample later. We're reusing code from this example in our script. So you can see that we start by importing the system module and the Adafruit _ DHT module that we installed earlier. Here you can see the types of sensors that are supported. There's the 11, there's a 22, and there's a 2302. You can figure out which one is which. Sometimes the sensors themselves have got that information printed on the board. So you can see on the sensor itself, the package. So you can see that this one is the AM2302, and that's how I knew which one of the options that the library gives me I should use. If you're not sure which one yours is because perhaps it's not printed on the package, then you can try them all and see which one gives you correct results. This is where the script receives the information from the command line in order to configure itself. So this is how we grab, say, the first argument from the command line and store it in the sensor variable, and that's where we get the second argument and store it in the pin variable. But for us, the interesting thing happens down here. This line is where we take the reading after we pass the sensor and the sensor type and the pin number parameters. We do a read retry, and this function will do multiple assignment and simultaneously assign the humidity value in the humidity variable and the temperature value in the temperature variable. And we print out these numbers down here and format them as well. So we use the print command, and you can see that we print out temperature and humidity as floating point numbers. That's what the F stands for, with 1 decimal point for each one. So there's 1 decimal point and 1 decimal point floating point number. Anything between these curly brackets is a placeholder. So we've got 2 placeholders, one for the temperature and one for the humidity. And the placeholders are filled with actual values by placing those values inside the format function. So as you can see, format here, open parentheses, we've got as many parameters as we have placeholders in between the single quotes here. So in between those single quotes, we've got 2 placeholders. We need to have as many variables inside the format parentheses, and the assignment is 1-on-1. Temperature, the first parameter inside format, will go and replace the placeholder, the first placeholder, and then humidity, being the second parameter inside the format function, will be used to replace the placeholder that is in the second position. Go ahead and play around with this script and with the sensor. Make sure that you understand how it works. You may want to do a little bit of additional research to learn how the print instruction and the format instruction work, and how to format a value using those placeholders. That will be a time well spent before you move on to the next lecture.